When factoring trinomials, you need to factor out any negative or greatest common factors before factoring completely. The reason is, if you don't, you're going to get all kind of crazy numbers. So I'm going to take a look at my very first example. I see here that my leading coefficient, this guy, has a negative in front of him. So I'm going to take the negative one out. Negative, and everybody's going to change to the opposite sign. Now I'm going to take A, multiply it by C, and I get 24. So I need two numbers that will multiply together, give me 24, and add together to give me positive 11. I don't know what they are, so I'm going to start at the beginning. 1 and 24, 2 and 12, 3 and 8. There's my numbers. So now I'm going to utilize these to change my B value into two separate values. So everything that I'm writing in red is not going to change. Everything that I'm writing in the other color is going to change. Now I'm going to factor out here in the green section. So my negative stays in place. Here I see they both have 3x in common. What I'm left over with is 2x plus 1. Over here in the blue section, I see they have a positive 4 in common. And what I have left is 2x plus 1. Noticing that what is on the inside of the parentheses on each of them is exactly the same. So now I'm going to go ahead and go through and combine like terms. I'm not going to forget that negative that's out front. 3x plus 4, 2x plus 1. Now, in order for me to ensure that I got this exactly right, I'm going to go ahead and plug these in my calculator. Remembering in the last video, I showed you that if we plugged in our factors individually, they should intercept at the x-intercept for this graph. If I plug it in like this, it should show the exact same graph. So I can check to see if something is individually a factor or if I factored everything correctly. So let's move over to Desmos. So I'm going to type in my original equation. Negative 6x squared minus 11x minus 4. And now I'm going to type in my factors as I found it completely done. Negative, parentheses, 3x plus 4, close parentheses, open parentheses, 2x plus 1, close parentheses. And if you notice, Desmos has kind of done most of the work for us. They have shown us that these graphs are exactly alike. So I'm going to go ahead and test these individually. So 3x plus 4. And look at that. It intersects exactly right there. Let me try the other one. 2x plus 1. And it intersects exactly right there. So yes, these are my correct answers. So if this was equal to 0, I would say that x is going to be equal to negative 4/3 and also negative 1/2. And those were exactly the x-intercepts that I found. Next example. Here I see that all of them are multiplied by 5, or a factor of 5. So I'm going to remove my 5 and write down what's left over. It doesn't look like there's anything else left there for me to factor out, no leading coefficient negative, so I can proceed with doing all of my steps. So first thing, A times C, add together to give me 11. I'm going to start at 1 and 10, and those are my numbers. So I'm going to split apart my middle term. And I'm going to go ahead and factor the first set. So 5 into x plus 1 plus 10 into x plus 1. Noticing the inside of the parentheses is exactly the same, so I can combine like terms. And this should be completely factored. If this is correct, I should have x-intercepts at -10, -1. So, let's go ahead and plug this into my Desmos calculator to ensure that this is my correct answer. So first, I'm going to go ahead and clear all these out. Now I'm going to go ahead and plug in my original equation. 5x squared plus 55x plus 50. I'm going to hit this little home button and zoom out a little bit just to kind of see what it looks like. So it looks like I have a couple of different items here. It looks like the graph is really vertically stretched. And I also see that I have an intercept at -1 and -10. So let me go ahead and verify that my factoring was correct. 5 parentheses x plus 10, close parentheses, x plus 1. And look, that graph completely overlays that graph. And I can verify this by turning the graph on and off. Okay, let's check them individually. X plus 10, x plus 1. And look at that. They exactly line up on those x-intercepts that I witnessed in my initial quadratic equation. So, there's a special kind of quadratic factoring that we can do that's called the difference of two squares. It's written in the form a squared x squared minus c squared. It has to be two terms, no b value. And I have to take the square root of a and c. So, remembering that my a and my c must be exact perfect squares. So if I take all of my numbers, 0, 1, 2, 3, 4, 5, and continue on, and I square them, the numbers that I want to see have got to be one of those numbers that are over on the right. It's got to be 0, 1, 4, 9, 16, 25, always. So it's got to be one of those kind of numbers. So let's look at the first one. 81, yeah, that's 9, 36, that's 6. Okay, they always follow the pattern of a squared x squared minus c squared equals a x plus c a x minus c. So let's go ahead and take that. This would be 9x plus 6, 9x minus 6. Okay, so let's look at this one. Well, actually, let's go ahead and verify that these are correct. So I'm going to go ahead and I'm going to plug these into Desmos. So I'm going to clear these guys out. And I'm going to start typing my original equation. 81x squared minus 36. There it is. So I should have x-intercepts at 2/3, negative 2/3. So let's verify the first one. 9x plus 6. Right exactly on the x-intercept. 9x minus 6. Exactly on my x-intercept again. Let me verify by putting them together. And let me turn these guys off. And I want to make sure this purple graph overlays the red graph, and it does completely. So that is my correct answer. All right, so let's look at the next one. 25x squared minus 256. So I know 5 times 5 is 25, and I know 16 times 16 is 256. So let's go ahead and break this down. 5x plus 16, 5x minus 16. Okay, let's verify this. So let's clear all these guys out. Here's 25x squared minus 256. And let's go ahead and write in my factors exactly as I saw them. 5x plus 16. It overlays exactly on my x-intercept. 5x minus 16. There it is again on my x-intercept. And then finally, 5x minus 16 times 5x plus 16. And you might notice that I wrote them in the reverse order, remembering that we can multiply in any order we want to. So I'm going to turn off the red and the blue and the green, and I'm going to verify that the green is going to completely overlap the black one. And it does. So those are my answers.